Last lesson for HL, and just to tell you this, the preface on this does not come up often at all in the calc option. It's possible. I've seen it, I think, on one paper, but there's two things that do come up, and I've seen a couple times. One, how to put things in sigma notation, just a technique on that one. And then, in other words, generalizing these patterns. And the other thing is, how do I get stuff to look like a factorial? So, here we go. First one, use Maclaurin series to write the following sigma notation. If it's sigma notation, we're asking for something like this. Okay? So we put in f of 0. This will equal 1. Take the first derivative. Plug in 0 for that. I get negative 3. Then I'm going to go 3 times 4. Negative times a negative. 1 plus 0 to the negative 5. And I'm going to leave it as 3 times 4. This is the first thing. If I'm sigma notation, I got to figure out patterns. And then I get negative 60. 1 plus 0 to the negative 6. But realize this is the same as negative 3 times 4 times 5. Next one should be 3 times 4 times 5 times 6. Now, if we're using Maclaurin series, this is my constant term. This is next to my x. This is next to my x squared over 2 factorial. Next to x cubed over 3 factorial. And this one would be next to my x to the 4th over 4 factorial. So that brings me to this point. This is what my Maclaurin series is. First one, for me, I'm going to just drop down and point a couple things on this one. If I see a pattern that maybe the first one doesn't quite fall into, then this just gives me the possibility off of this one. So I'm going to drop the first one down, 1 plus, and I'm going to do the rest of this with a sigma notation. So I'm going to start at n equals 1, go to infinity, and then I got to figure out the pattern. Well, if n equals 1, I'm going to take care of that negative sign, because it goes from negative, positive, negative, positive. So I can just do negative 1 to the n. That takes care of my negative sign. Now I don't have to worry about that. I can also take care of the denominator, because whatever it is, whichever term it is just n factorial. Okay? Then on the top one, I notice that if this is 1, that's my n on this one. So I can go x to the n on this one. Then this one is how I have to, this is where it gets a little bit trickier. And I can look at the 4 on this one. I can look at the 5. I look at the 6. And I realize, oh, it's plus 2. To whatever n is, it's plus 2. So that gives me n plus 2 factorial. The one problem with that, I'm missing a 1 and a 2. 1 times 2. I'm missing a 1 times 2. Missing the 1 times 2. So the easy one on this, if I did the n plus 2 factorial, it would include the 1 and 2, but I can just get rid of it by dividing by 2. So that one gives me the sigma notation, and I just want to emphasize a couple things. I didn't simplify, so I didn't have to figure out the pattern. I figured out each individual pattern. If I don't see the pattern on the first number, then I just drop it in the front. Okay? So that's the first thing, is don't simplify. Don't reduce, don't do anything like that. Brings me to the second one, use sigma notation for this. So to the 1/2 power. Same thing, Maclaurin series, 0, f prime of 0, f double prime of 0, f Now, this is where I want to emphasize sensing the pattern on this one. If I get the pattern, and I'll show you in just a second what I mean by this, I get 1/2, 1 plus 0 to the negative 1/2, which equals 1/2. This is going to be 1/2 times negative 1/2. I wrote that backwards, but you guys know, to the negative 3/2, which equals, and I'm going to write it this way, negative 1/2 times 1/2. Okay? The next one is negative times a negative, so positive, 1/2 times 1/2 times 3 over 2. The next one would be negative 1/2 times 1/2 times 3 over 2 times 5 over 2. So just to emphasize what I'm doing on this 1 plus 0, subtract 1, I get negative 5/2. derive that one. I end up plugging in 0 for x. I get this one here. All right, so not simplifying. That's the key part because ultimately I got to get it to sigma notation. I end up with this. Now, here's what I want you to notice. First term, positive. Second term, positive. Third term, negative, positive, negative, positive. This messed up my pattern for just the negative signs. I don't know how to keep on flipping it. Once I get past that, it's every other one, and it makes sense. And if you look back at this, I went from a positive exponent to a negative exponent, and then I keep multiplying by negative numbers. So the first one doesn't fit my pattern. So I take the first one, I take it out of my pattern. So now I'm just looking for sigma on this one. I can start at n equals 0, n equals 1, it doesn't matter. For me, let's see, what did I do? I did n equals 0. Okay? Now, here's where it gets a little bit tricky on this one. Okay? For the bottom one, obviously, whichever one this is, I got x to the n plus 1. If I do n equals 0, I got to make sure that, and remember what I'm starting here, that this is 1. So I need to plug in 0 and get 1. So I get n plus 1. Okay? That also gives the bottom is n plus 1 factorial. Okay? And there's more than one way. I could start with n equals 1 on this, n equals 0. Just showing you a different way on this one. In fact, and I'm not going to erase this, I apologize for this, I think I will just go to n, because I'm starting to see that right now. And sorry about doing this, but I've messed up so many times I'm not going to go over again. So that gives me x to the n, n factorial on the bottom. So the n is here, here, n factorial here, here, works out for that one. 2 to the n power, and you realize over here I got 2 of them, 2. Then the tricky part is once I get to this one, the numerators. I'm just looking at the numerators, and this is the tricky one on this whole thing. So if I just look at that pattern right there, I got a numerator of 1, followed by 1, followed by 1 times 3, followed by 1 times 3 times 5, followed by 1 times 3 times 5 times 7. Definitely pattern here. This is another problem. So you might start on the third term if you wanted, if you saw it this way. I have this pattern that I realize when I get to, say, x to the 4th, that I end up doing an odd, starting with the highest one being 5. Okay? But when I do 5, I get this weird pattern of starting with 7. So what I end up doing, and this took a little while, I realized what I'm doing is doing 2 times n minus 3 factorial. And you can take a look at 4. 4 times 2 is 8, minus 3 is 5. Okay? So, but the problem with this is that's not exactly the pattern because I'm missing all the evens. Now realize what I'm saying here as I copy all this over so I can have more room. Or actually I can just go to the next one. The problem I have is this numerator ends up being 1, apologize, 1 times 1 times 3 times 5 times, and it just keeps on going this way. All the way to the 2n minus 3. It's not factorial, that's the problem. So 1 times 3 times 5 times 2n minus 3. Here's the tricky part, okay? And let me just kind of emphasize this with new paper on this one. If I have 1 times 3 times 5 times 7, this goes all the way up to the 2n minus 3, okay? If I go all the way to the 2n minus 3 on this one, and so far I have this 2 to the n times n factorial times x to the n can kind of take that out. I can't write this out for every single one because how do I write the odds? So here's the trick. So here's the second part I wanted to talk about. I'm going to multiply by 2 times 4 times 6 times 8 all the way to the 2n minus 2. Whatever I do on the top, I'm going to do on the bottom. Okay? So this is the key part on this one. If I multiply the top by that even numbers, 2, 4, 6, 8, and I'm just assuming I have all those numbers on that one. The top one, I realize this is kind of weird. 2n minus 2 is bigger than 2n minus 3. The whole top ends up becoming 2n minus 2 factorial. Because now I have all the odds from this side. Now I put all the evens from this side. Okay? That leaves me with 2n minus 2 factorial, 2 to the n times n factorial. And watch me break this part down. This is just 2. This, 2 times 2. This, 2 times 3. 2 times 4. Okay? Even to the last one where it's 2 times n minus 1. Let's factor out a 2. Which means this. If I look at all the 2's from those, how many of those do I have? I have 2 to the n minus 1. Okay? Realize this is telling me how many I would end up having on that. Okay? And then that leaves me with 1 times 2 times 3 times 4 times up, all the way to the n minus 1. Leaves me with n minus 1 factorial. So my answer to this one, by this little algebra step, let me see how I did this, is this. All right. I think that's enough for this. I'm going to stop it there. There is a memorization one, but it doesn't seem to work every single time. I don't see them doing anything without prepping you Maclaurin Taylor series. So you can try a few of these. On that one, page 121, this is all out of the calc option, the Hasten-Harris calc option attached to the Google site. Try that out. I'm apologizing for messing up, and if I lost any of you guys, please feel free, ask me questions whenever you can.